Hello, everyone. Welcome to Design Hub. Today, we're going to talk about one of the most fundamental topics in process design, line sizing. It may sound simple, but a wrong line size can impact plant safety, efficiency, and even cost. So let's dive in. Why is line sizing so important? If a pipe is undersized, pressure drop will be too high, pumps and compressors may overload, and flow restriction can choke the system. If the pipe is oversized, material and fabrication costs rise unnecessarily, and low velocity can cause solids to settle, leading to maintenance issues. That's why line sizing is always a balancing act. Not too big, not too small. There are four main criteria we check when doing line sizing. Number one, velocity limits. Each service has recommended velocity ranges. For example, liquid hydrocarbon lines usually run at 1 to 3 meters per second, gas lines at 10 to 20 meters per second, and multiphase lines follow the API 14E velocity formula. Number two, pressure drop. Every line has an allowable pressure drop, usually a percentage of the system pressure. Number three, erosional velocity. API 14E provides a formula for multiphase and sour service lines to prevent erosion. And number four, standard pipe sizes. After calculation, the nearest commercial size and schedule must be selected. Let's look at a simple step-by-step method. Step 1. Collect process data: flow rate, pressure, temperature, density, and viscosity. Step 2. Assume a velocity range based on the service. Step 3. Calculate the required pipe internal diameter. Step 4. Select the nearest standard size and schedule. Step 5. Calculate pressure drop using Darcy-Weisbach or Hazen-Williams. Step 6. Check erosional velocity and client standards. And Step 7. Finalize the line size and document the design basis. Here's a quick example. Suppose you have an oil line with a flow of 100 cubic meters per day, density 800 kilograms per cubic meter, and viscosity 3 centipoise. In this case, we use a velocity of 1 to 3 meters per second. The calculation points towards a 3-inch nominal pipe. After verifying pressure drop, the final recommendation could be a 3-inch Schedule 40 line. Now, let's talk about the common mistakes engineers make in line sizing. Mistake 1. Freezing a line size just based on velocity, without checking pressure drop. Mistake 2. Ignoring vendor availability and fabrication constraints. Mistake 3. Not documenting the design basis, which is always required by clients. So friends, today we've seen how line sizing, though simple on the surface, is actually the backbone of process design. Correct line sizing saves cost, ensures safety, and improves plant performance. If you found this discussion useful, don't forget to like and share the video, and subscribe to Design Hub for more such engineering insights. I'm your name, and I'll see you in the next episode with another exciting topic. Thank you.